So here we're asked to write the domain and range of the following graphs. So the domain is x and the range is y. So looking at the domain of the first function, the domain is going to be along the x-axis. So it looks like here it starts at 0 and it just continues on forever, and it takes on all values of x from 0 up. So the domain in this case, and I'm going to write this formally in set notation, x with a line, and x is greater than or equal to 0, where x is an element of real numbers. Okay, so this is a set notation. Really, we're most interested in this part here as the domain. Okay, the rest of it is just more of a formality. For the range, we can see that the range value starts at 2 and it's going to go up from there. So our range value, we write this way. So the range, again, I'm going to use proper set notation, y with that line to separate the argument. So y is greater than or equal to 2, and this is continuous, so y is all real numbers. Okay, and again, what's most important here is really this part here that really describes the range. The rest of it is more of a formality. If you're asked to write it formally, we need to write that set notation. So looking at the other one here, for x's, we can see that the domain is going to take on values of x, and it is continuous because if we look at casting a shadow down this way, onto the x-axis, it will cast a shadow all the way from 0 and all the way up to 6 with no gaps. So that's going to be my domain then. So I have my domain. It's going to be to do with x's. And x is going to be all real numbers starting from 0 and ending at 6. And there's no gaps in my domain. So I'm going to state that this is all real numbers. Okay, so that's the domain of this function. Now the range is a little bit different. We have to be a little bit careful with the range here because when we talk about the range, we want to know what kind of shadow it's going to cast on the y-axis. So if I have a light here, it's just going to cast a shadow there, nothing here, and we're going to cast a shadow here. Nothing in here and there. So what ends up happening is we end up with the range is a discrete function. So we're going to do it like this. The range is going to be y. And with discrete functions, it's easier to just list the different range values. So y is going to be 1, comma, 2, comma, 3. And we're not going to put y as all real numbers because that's not true. That's not the case. It's not continuous. It is discrete. So then I just leave it like that. Okay? Now, this is proper set notation. Because it is discrete, we do still have to, even if you're being informal with this, you still have to write those brackets to describe the range. For this question here, it says, which of the following relations can be produced by 2 over 5x minus 6? Again, the big idea is there's a slope that describes this line and there's a position that describes this line. And as long as the slope and position match, we can describe the line. So I'm going to start with the graph. Looking at the graph, I'm going to check for slope. So is my slope equal to 2 over 5? Okay, so I'm going to draw my slope triangle here. Now that's my change in y is 2, but I have to be careful because if I measure it left to right, it's down 2. Okay, so it's going to be negative 2. That's actually really important. I'm going to highlight that because if we're not aware of that, we may make a mistake on here. My change in x is going to be 1, 2, 3, 4, 5, so plus 5. So the slope is going to be negative 2 over positive 5. Now, right away, we can see that that doesn't match. Okay, so we can eliminate that. The y-intercept does match, so that is a distractor in this case, because the y-intercept does actually match, but the slope does not match. This is not the same. Okay, so we can eliminate 3. When we take a look at the graph that's graphing the points 15, 0, 10, negative 2, negative 5, negative 8, negative 10, negative 10, we just have to make sure that all those coordinates, every single one of them, can be applied to this relationship. Now, if I put 15 in for x, I do end up with 15 times 2 is 30, divided by 5 is 6, minus 6 is 0. So that point's okay. 10, if I plug in 10, I end up with 20 divided by 5 is 4, minus 6 is negative 2, that's okay. Negative 5, when I plug that in, I get negative 8, that's perfectly okay. If I put in negative 10 times 2 is negative 20, divided by 5 is negative 4, minus 6, negative 10, those all match. That graph, those points, can be all represented by that function. So that's okay. And then lastly, for this one here, for example, for number 1, the easiest way may be to just check by rewriting this equation as a y equals equation. So negative 2x plus 30, divide by negative 5. I'm going to end up with positive 2 over 5x minus 30 divided by 5 is going to be 6. So this equation, that one comes from there. It matches. Therefore, that's okay as well. So the answer to this are, which of the following relations can be produced by y equals 2 over 5x minus 6? Well, 1 and 2 both work. 3 does not work because the slope does not match.